Over here, we'll learn product rule, but before we begin, I'm going to show you one where we apply power rule, and then I'm going to show you the second one, which is applying product rule to the exact same terms that we want to differentiate. So let's say I want to differentiate x squared times 1 minus x. I can expand it, and I have x squared minus x cubed. And let's say I differentiate this, applying power rule, we get 2x minus 3x squared. So let's say right now again, we do the same one, and we apply product rule. So when I say apply product rule, we are looking out for two terms, u times v, whereby both u and v are functions of x, that is, they contain x inside. So if I want to apply product rule, right, and differentiate u times v, we apply this product rule, which is u dv dx plus v du dx. So if I put it in simple words, is the first one times differentiate second plus second times differentiate first. So let's do this. So dy dx is the first one. So I copy down the first one times differentiate second. So I differentiate the second one, which is minus x minus 1 plus the second one, which is 1 minus x, times differentiate the first one, which is 2x. Simplify it. We'll get the exact same answer as above. So why do we want to apply product rule when we can also get the same answer when we expand? So let's look at this. Isn't this expansion tedious? Let's say the power is very high, or even larger, the power is at power 5, power 6. By then you expand everything, it's going to be very tedious. Likewise, if you have this u times v, where u is 3x plus 2 multiplied by square root 4x minus 1, it's going to be impossible to expand this before we want to differentiate each term separately. So therefore, we need to learn product rule. So let's say for this one that is very tedious, I apply product rule again. So our dy dx is the first one. So that means this is my first term u. This is my second term v. So since I have u times v, so x squared times 4x minus 1 cubed. So I mentioned times, it means product. So when we see something times something, we can apply product rule. That's what's the meaning of product, multiply, times. So the formula here, u, which is the first one, so we can copy down x squared, differentiate 4x minus 1 cubed. Okay, we must apply chain rule. Multiply by 3 4x minus 1 square, differentiate inside the bracket, and we get 4 plus v, copy down the v, multiply by differentiate the first one, which is times 2x. So right now, if we simplify it, we have 12x squared What is the next step to do? Recall that we have learned factorization. Why? Can you see these two terms? Can we factorize? Can we factorize the 12 and 2? Can we factorize the x and x squared? So for example, if let's say x squared plus x cubed, how are we going to factorize it? So if we want to factorize this, we take out the highest common factor, which is x squared, and we got 1 plus x. So which one do we want to take out as a common factor? The one with the lower power, 2 as compared to 3. So if I do this slowly, I take out a 2. Alright, let's take a look at this one. What about x squared and x? So I got take out x. And what about 4x minus 1 square and 4x minus 1 cube? Take out the 4x minus 1 square. And then inside over here, I have times 6x plus, so 4x minus 1 square and 4x minus 1 cube. Right, I'll take this one, divide by this one, and over here inside it will be 4x minus 1. Simplify inside the square brackets, we will get this as the final answer. Okay, so we have learned how to apply product rule. So remember, memorize the formula d dx u times v is equals to u dv dx plus v du dx. That's all for this video.